Okay, so hello everyone. Okay, can anyone hear me? No, you can? Okay, thank you. Okay, so hello everyone. My name is Yifang Wu. Okay, I'm a psychometrician at ACT. Yes, I'm physically at ACT right now. Okay, so in August 10th, there's the Rachel hit Iowa and Illinois areas quite serious. And technically, I lost power at home for a few days. And as I know, our discussant, Dr. Deborah Harris, she suffered the same thing as well. And Young and Wei, they both had lost power in home for a few hours. But those in Iowa City and Cedar Rapids, they got a big hit. And then a few days later, in a Sunday afternoon, I lost power again. So I started to get scared. I wouldn't know what would happen on this presentation day. And last straw, last straw on the camel's back to make this decision to us is this Tuesday morning. The other two presenters, Young and Wei, they lost power, in their Corville home. So it's like we make this decision at the very last minute to come to ACT physically to give you this presentation. So first of all, I want to thank the ACT facilities to approve this for us. And I want to thank Jamie, our secretary in research, to go through the communications for us. Just so you know, to protect staff safety, we're still working from home right now. And to keep everybody's safety, Young, Wei, and I, we now are staying in different rooms, physically at ACT. So we are a small team, working for a K-12 testing program in ACT. And today, we're going to present a study that is conducted recently, and it tackled down some issues. They are not new issues. Pre-equating, there are a lot of technical psychometric considerations you have to tackle in moving from post-equating to pre-equating. And luckily, we have the chance to design a study and then to investigate some questions that people ask us and we ask ourselves. So Wei is going to present you the study design and the wrap-up analysis, for us. And then Young is going to take the big lifting to describe, the main core issues that we are investigating and then the analysis for this study. And then I will wrap up with another experiment and then concluding remarks for this whole session. And yesterday, I was asked by our senior director in the department. She's like, encourage us to give everybody an advertisement. I go, yeah, you got to tell your colleagues that you're doing this, so tell us, tell everyone that you will be doing a session today to share everyone a study that we have fun with and we want to present the results with. And then in my advertisement email, I use Deborah Harris as a selling point. Like, if you want to listen to Deb Harris, come to this session. if you haven't seen her for a long while, log in to see her. But just so you know, we're not going to let her talk 1 hour from now. So you'll have to wait patiently, 1 hour. So you'll be able to see a depth with comment, on our study. So thanks everybody, to be with us today. Now I'm passing the microphone, to Wei. So Wei, it's yours.
Thank you, Yifan. Let me share my screen. Can you see my screen okay? Okay, can you hear me okay? Oh, good morning, everyone. Thank you very much for joining our symposium session this morning. Our title is Feasibility of an Embedded Field Test Model in the Enhancement of Preequating. So before we start, we would like to say thank you to a few friends and former colleagues, Dr. Yifan, Dr. Troy Chen, who had also worked on this study before. And also thank you, Dr. Deb Harris, for your insights and innovative ideas at the very early design stage of this study, and also your time of reading our papers and discussing, and especially thank you for your patience waiting for our papers. Okay. So there are 4 papers in this symposium, as Yifan mentioned. I am going to present the first 2. So the first paper is around introduction to the study objectives in data collection design. And the remaining 3 papers are analysis centered around the same topic. So some practical questions if you've worked in a testing company, either posted by the operation department or our customers. What can we do to shorten score reporting time during the operational window? And if you are a psychometrician and your testing program currently uses, post-equating method, then maybe you will be asked a question of, can we switch from post-equating to pre-equating so that we can save the equating time during an operational window? Well, the answer to this question is yes, maybe, but not guaranteed. Especially if you have a program, a testing program like ours, with constructed response items to be scored by human beings. The time scoring constructed response items typically takes longer than equating. So it may not necessarily shorten the reporting time. But to a certain degree, it does provide an easiness in test administration during an operational window. So typically during a testing window, there are so many things you need to take care of, not thinking about data collecting, you have the right data to do equating. It's just like a one thing off the mind. But this is like easiness during the operational testing window, not necessarily before and after. So when you move to pre-equating, you need to worry more before test really happens. And also, if you're thinking about changing equating methodology for an existing program, there are issues you need to consider, like how would you maintain score comparability before and after the change, right? I believe for most cases, you want to maintain the scale, or in a few cases, you don't want them to be comparable, and that's totally fine. And that's actually an easy way to move forward. But I believe most people would like to maintain the scale to reduce the inconvenience this may bring to our customers. And whenever you have changes in methodology, there are potential impact on student scores. So other than this, when we move from post-equating to pre-equating, there are other things you need to consider. And this is not going to happen overnight or over a year. This involves, a careful planning of studies and examinations of, the impact. So I think the most important thing is you need an optimal pre-testing model. So I'm going to stop here because I'm going to talk about this in the next slide. You also need a relatively larger item pool because under pre-equating, typically you have more requirements and more strict rules on item stats to assemble like forms. So if you have a relatively shallow item pool, you may run out of good items to have parallel forms. You also need to consider what is the proportion of pretest items and operational items in the new form. Testing mode. If your testing program administer tests on both online and paper, then you need to consider, do you need to pretest items separately on different modes? Or can you use items pretested on one mode to do pre-equating on another one? So, and then you need to have studies planned. And then there are like, practical constraints you also need to consider. So for the pre-testing models, so we think one key factor to have a successful pre-equated form is the stableness of item stats. So if the items have really stable stats between PT, pre-test or field test, and later when they are in an operational setting, if they are really stable, then you will have a nice, good comparable pre and post equating results. So there are many earlier research have shown that, a stable item stats mainly depend on the, context effect or cost by context effect. If you put items closer to where they are going to be in an operational setting, then the item stats are pretty stable. So the most flexible pre-test model is you place your pre-test items to where they will be placed as operational items. This is flexible, but they are constraints. This indicates that your system needs to be really flexible to keep variable positions for pre-test items. So other than this, you can put pre-test items in fixed positions, but the positions are spread out through the entire operational form. For example, you can reserve item number 5, 7, 8, 10, or 5, 10, 15 to pre-test slots, and then you can pre-test them, and then later on you can place those pre-test items in positions closer to where they were pre-tested. There's also another one. So you can have fixed positions bundled together, and then it's the beginning, middle, and end. I believe under the pre-equating setting, most people would like to put fixed positions in the middle instead of in the beginning or at the end. So that's the pre-testing model. A selection of pre-test model is a critical factor for pre-equating. So now back to our study. So our testing program, currently we use equate percentile post-equating. And by the way, in this session, we use equate percentile pre-equating and CTT post-equating interchangeably, acknowledging there are differences between those. But for notation purpose, we use them interchangeably in this session. And the proposed one is pre-equating, and it's IRT-based pre-equating. And after considering some practical constraints, we feel that the pre-test model that suits us the best is this one, is fixed positions bundled together in the middle of the test form. So that's the model we are considering in this study. And really the research question or objective we would like to achieve is we'd like to see to what degree do pre-equating results based on the embedded field test data agree with post-equating results based on operational data, so that we can claim scale scores are comparable between before and after this methodology change. Okay, so the data collection design online form. So, and this study happens during an operational testing window. So we have a new form. As you can tell, we reserved a fixed position bundled together in the middle of the form as our PT slot, field test slot. We also have a base form. Again, for this study, the PT items or the FT field test, sorry, I use PT and FT interchangeably. So between these two forms, the pretest items are identical. But the operational items, no, there's no overlapping. So under the pre-equating scenario, for the new form, all the items would have been pre-tested with nice item stats so that we can do IRT-based pre-equating and come up with a conversion. However, in this case, this is our year one. We don't have any historical information to do this. So we are just trying to mimic what this is going to be in a real situation. So that is, how can we put these items in other forms and pre-test those? So to make this happen, we cloned 4 forms based on the base form X. And we call them study forms X1 to 3, and 4. The cloned forms have identical operational form as the base form, leaving the PT slots open. And then we broke out the new form into multiple sections and put those sections into into the PT slots of the study forms. So they are 4 study forms. This is because of a operational constraint, and we can only have 4. So sometimes for some tests, 4 forms of pre-tested items cannot make up a new form. So there are some additional operational items left over. So even though I put the additional OP at the end, this doesn't mean that all the additional OP items are at the end. They may be somewhere, under A, under B, or under C, under D. Just for easiness in presentation, I just put them at the end. So this is the form construction form construction design. And all 6 forms, so 1 base form, 4 study forms, and a new form were randomly spiraled at the student level so that we have equivalent random groups. And data collected during an operational testing window. And we selected 4 tests, so 2 subjects by 2 grade levels, English grade 4 and early high school. So for our early high school test, it really covered grade 9 and 10. So grade 9 and 10 students took the same test. And this, the early high school tests are appropriate for those 2 grade levels. And also science grade 3 and 7. So item type, we have 3 item types for online forms: selected response or multiple choice items, technology enhanced items, and constructed response items, of which selected response and technology enhanced items are dichotomously scored 0, 1, and constructed response items are all polytomous items. So here is a table showing the number of items. In this is consistent with the number of items showing here. So they are operational items before, PT items and after. And the number of items are the same across these forms. So we have 4 tests, as mentioned earlier. And all the pretest items are in the middle, so you can tell how many PT items we have. So it's 8, 12, 6, and 6. And then this shows the total number of operational items for each of the 4 tests. And the last column shows how many of those operational items were distributed among the 4 forms, A plus B plus C plus D. So for English grade 4, we were able to put all operational items in the new form and distribute it among the 4 forms. And there's actually 1 extra slot. So 1 item used in 2 study forms. For English grade 9, we won't be able to test all 50, but we distributed 48 out of 50 into the 4 forms, so pretty good. But for the 2 science tests, we only pre-tested 24 out of 32 and 36 items. So that's number of items. And then we have 3 sets of analysis conducted. So the second set of analysis, basically we want to say, so this is our base form, right? And we embedded different set of PT items. Very likely this set of items are at different level of difficulties. So when you insert items at different difficulty level, will that impact students' responses to subsequent operational items? If yes, do we equate each of those forms separately? Well, if no, then we can combine those and do the equating. We don't need separate conversions for forms with different PT sets. So that's actually our second second paper first analysis. And then, so based on this design, the third paper talks about the new form conversion. They are really 2 ways of doing conversion, equating. One, based on this design, we can follow the operational practice to equate form y to x using random equivalent group percentile equating, right? And then, so this is our baseline to be compared with other equating methods. So the other is we can calibrate items from A, B, C, D, and then we treat them as known stats and come up with the conversion table. And in that case, we will have a shorter form. So in this case, we'll have item stats only for those A, B, C, Ds. And for the additional operational items, they are based on a float calibration of this form. And more details will be discussed. So at least there are 2 equating methods. So that's actually our, so this one I mentioned paper 2 to check, different PT items impact on later operational items. And analysis 3 is we compare the equating results of the new form. And earlier I mentioned that this equipercentile post-equating is the current practice. And then IRT-based pre-equating is what we proposed. But in reality, there is really a equating method in the middle, the IRT-based post-equating. Because when you compare number 1 and number 3, the data collection, like pre-post, is confounded with methodology, equipercentile versus IRT. So when we see big difference from the first one and the third one, we would like to further partition them into, what may cause this. So when we have this additional conversion, we can compare, between post-equating, whether equipercentile versus IRT is similar, and between the 2 IRT method, whether pre and post is similar or not. So that's the third paper. For the fourth paper, okay. So earlier we talked about this data collection design for online forms, right? For our testing program, we also have a paper mode. So we have a paper form, paper-based form. The only difference between paper-based and online-based is the technology enhanced items on online forms. So for the online-based form X, we have a couple of TE items. and we cannot administer those on paper form. So we replaced the TE items, technology enhanced items, with the multiple choice or selected response items equivalent to the TE. But 95% of the items are identical between the online base and the paper base. And similarly, we have a new paper form that is also sort of, with 95% items identical to the online form. So our third analysis, or paper 4, we would like to see, can we use item statistics pre-tested on online forms to pre-equate the paper form? So we do equating within mode. So within this online, these 6 forms are random equivalent. And in the paper world, in the paper schools, the new form and base form are also random equivalent. So this design, this is the basic design. So that's actually, that concludes my first part of the presentation, introduction and study objectives. Then I'm going to move to the second paper. So mentioned earlier, the research question is, when different set of pretest items with various difficulty levels are embedded in the middle of an operational form, do students perform differently on subsequent operational items? So this table shows the average item difficulty and point by serial of the PT items in the slot of A, B, C, D. So they are, 8, 12, 6, and 6 items. And then when we compare the p-values, the ones I highlighted, or the red font text, are the minimum and the maximum average p-value across the 4 forms. For the average point by serial, they are similar, reasonably similar. So those are the basic situation. And then when we compare those PT item sets, the largest difference in difficulty is about, like for this one is 0.2. And then this one is 0.27. For this one and this one, E9 is S7, it's around 0.0. So now we check for each of the tests. You see 4 charts, and each chart represents one statistics being looked at: the p-value, point by serial, A parameter and B parameter estimates. And then within each chart, we show the average, standard deviation, minimum, and the maximum of the statistics. So for this one, if you recall, for English grade 4, the biggest difference happens on A and B, and maybe our focus is on A and B in X1 and X2. And when you check their p-value of the operational items after this, they really don't differ much. And then actually all these 4 stats, they look pretty similar. So this is E4. And then this is the early high school English test. Again, they are similar. And then this is science grade 3. Again, similar. And then science grade 7. So basically they are very similar. So some concluding remarks on the first analysis. So simply put, the CTT and IRT stats of the operational items that were placed after the pretest sections were considered comparable across the 4 study forms. And we could conclude that the impacts of varying average item difficulties of the pretest sections on operational item performances was trivial. Yeah, and then, we have similar conclusions based on other investigations. That's all I have. So I'm going to turn this over to Yung.
Thank you, Wei. Let me share my screen. Okay. Sorry. Thank you for attending this symposium. And now we look at the comparison of CTT post-equating and IRT pre-equating in this field test model. And the purpose for this part of study has two folds. The first at the form level, and we just compare the final reported scale score obtained from the either CTT post-equating, IRT post-equating, and IRT pre-equating. So at this level, we just try to find out whether there are differences among these equating methods. Then we go a little bit deeper at the item level. So we try to compare the performance of items embedded in the study forms as compared to the new form. In this study, we also touch base the context effect. So there should be a lot of things, and we have we need to answer several research questions in this set of study. Now let's go back to the study design. Yeah, because it's the backbone of this study, and if we get familiar with this design, it's easier for us to understand this study. And in this study, please focus on these elements: the OP items, OP1, OP2, and the field test items A, B, C, D, and the additional OP items in the new form. So basically, we will doing research related to these items. So in this study, as mentioned by Wei, we have 4 tests, and English 4, English 9, and Science 3, and Science 7. And because we're doing IRT study, we need to calibrate items, and we use a 2PL model to calibrate the dichotomous items, and the GPCM for polytomous items. For evaluation, we separate into 2 levels, as mentioned in the purpose of this study. At the form level, we basically compare the difference in equating methods on the reported score. So we look at the raw to scale conversion. We look at the students' reported scores, and then we move to the item level comparisons, and we basically compare the item level performance between the field test sessions A, B, C, D in the study forms, and the OP items in the new form Y. And the things we look at including the p-value and point by serial correlation, and IRT, the A and B parameter estimates. And also we look at the response time and item omit rate. So based on this item level analysis, it just gave us some idea how item performance can affect the overall test scores. And as mentioned by Wei, we have 3 equating methods. And the first one is equipercentile method. And because it is our current practice, so it is treated as a baseline for comparison. And basically, we just under this random group design, we do the equipercentile equating on these. And the second method is IRT post-equating. Under the same random group design, we separately calibrated these two forms, and doing the since it's a random group design, these two scales are on the same scale. So we after calibration, we do the IRT true score equating. And for the pre-equating, IRT pre-equating, we do the fixed parameter estimate for the OP item from the baseline. As shared by Wei, because the study forms and the base forms basically have the same OP item set. So once we calibrate the base form and then we fix the item parameter estimates from the base form, and we calibrate the field test items A, B, and C, and D in the study forms X1 through X4. And then we obtain the additional OP items from calibration results from the new form Y, and mentioned in method 2. So once we have the item parameters estimates from of A, B, and C, and D, and additional OP items, so we use these item parameters to obtain other conversion tables. So now let's move to the results. First, let's take a look at the overall results. What I mean, overall results, it gave us a general idea of the comparison of the skill score and the passing rate. From the table, we can draw two conclusions or two findings. The first thing is the results between IRT post-equating pretty close to CTT post-equating. We can see that there's one exception for the IRT post-equating. And generally, we can see that IRT pre-equating has a larger difference from the CTT post-equating in terms of a mean scale score and the student passing rate. So that's the finding in this overall science. And then we just try to figure out why IRT pre-equating is different from CTT post-equating. So we just go a little deeper, and we found out that first we separate the students into different groups based on the difference between IRT pre-equating and the CTT post-equating. If we can see there are 4 groups, and that's the difference of skill score, mean different mean skill score. So it's either decreased by 1 point and no change, and increase 1 point and increase 2 points. And from this table, we can see that a large percent of students has score changed. For example, for E4, we have a 40% student decreased skill score. And for science 3 and 7, we can see decrease of skill score. And for the English 9, we found the opposite increase. A large percent of students has an increased skill score. So when we see these a large percent of students has a score change, we just see why this happened, and then we went to the raw to scale score conversion. And from this table, we can see that this axis is the raw score, and the y-axis is difference in reported skill scores. And what we mean difference is either IRT pre-equating minus a CTT post-equating. That's the blue line. And the other one is IRT post-equating minus a CTT post-equating, which is the red solid line. And we can see from this raw to scale conversion that we hope that it should be a straight line at the 0, but we can see there are either some part decrease and some part increase. And as compared to the IRT pre-equating and IRT post-equating, we found that the IRT pre-equating has some a larger difference than the IRT post-equating as compared to the CTT post-equating conversion table. So that's the overall information we have. So once we have this difference found in this method, we just try to figure out why, and then we dip a little bit deeper, and then we just do some analysis at the item level. And here we have two examples. One is for English 4, and the other one is Science 7. Because this English 4, we can see that the difference are not large, and the 7 we have larger differences, and at some point we can see the two points of increase. So before we move to the item level results, we just go back to the design again, and we just pay attention to the position change. And for the A and B in the new form, we can see that these two forms basically just move late in a later position of the in the study form. And for C and D in the new form, we can see that it's a move. It's appeared earlier in the study forms. And when we calculate the difference, we use these operational items from this new form, A and B and C and D, minus the field test items and A, B, and C and D. So in this item level results, we look at many things, and I put it in one slice for one subject and one test. It looks like kind of messy, but we'll get it. Okay, yeah. So let's look at the example for larger changes of Science 7, and in this figure, we have, in this slides, we have 6 figures, and in 3 columns. And all the figures are different between the OP item, again, OP minus the field test in the study forms. And the first column, we have a point-based serial and A parameter estimate. In the second column, we have p-value and B estimate, basically the difficulties. And the third column, we have latencies, and that's in second. And this one is omit rate. For the x-axis is item position. What I mean item position is the position in the new form. when we come back here, we just see the item position in this form, new form Y. Okay. For the y-axis, that's the difference. Difference. Okay. Now let's take a look at the results. And when we look at the dots, we can see there are 3 types in Science 7, and the circle means multiple choice or select as a response, and the plus is the TE items, and the cross is the CR items. And yeah, I know that this figure is kind of messy, but we can find a general trend in this study. When items appear earlier, we can see that there's some less discrimination, and the items are easier. And we can see there are more time spent on the items. And we can see that the less omit rate when the items appear earlier. The same thing is true when items appear later. We can see that the discrimination increase and difficulty increase and spend less time, and there are more larger omit rate. And for E4, we can see the similar things, but the point is the pattern is not very clear. We can see not as clear as S7. So the difference also is smaller. So yeah, that's why it's an example of smaller changes. So now let's go to the conclusion from this study. The first thing is differences among equating results are found. And we can see in this study, the IRT post-equating and the CTT post-equating results are similar. So that means if we move from CTT post-equating to IRT post-equating, the effect is small. But when we move from post-equating to pre-equating, we can see that it leads to larger differences as compared to the baseline. And we noticed that the changes, not only at the overall score level, we can see the changes also happen in item performance, but with a different subjects and different grades, the responses are different, the results are different. So at last, we can see that the context effects are not conclusive, because some context effects were found, but not in all the tests. Yeah, so basically that's the study for paper 3, and I will stop here and give back to Yifang for paper 4.
Okay, so hi everyone again. Can you see my screen? Yes? Okay, thank you. So we thank Wei, to give us a good introduction of the study and the study analysis. And Yong, like I said, it's a big part, of the study. And as far, all the analysis that was done, were for the online forms. And in reality, I think it's interesting, right? We are all psychometricians, and people think we are psychometricians, so they come to us and ask. So you're doing all these analysis, on the online forms, but we have paper forms. Can you also please do something for the paper forms? Or, can you take such questions like what I'm going to show you right now? So this is a real scenario. I still remember that afternoon, Wei came back from a meeting and she said, well, this is a question people ask us. What do you think? And I don't think, it's a new question to Wei or to other psychometricians, in this psychometric world. So involuntary, we take this question. So when you transit from post-equating to pre-equating, can you use the pre-test items on your online forms to the paper form that you're going to create the conversions for? Well, I think this question, seems reasonable in a way that we know online testing is a trend. But I love that saying. I don't remember whether it's from Dr. Hoover or from Deb. Paper testing would never die. I think that is the truth, right? We are born to learn by our hands. Without pointing things, we learn how to pick up a pen or a pencil, started to do math, started to do characters. So we learn things by our hands using pens or pencils. So a lot of times still, we see kids, younger kids or ourselves, we solve problems on paper. I recently talked with a high school friend. When I say high school friend, I mean she's a high school student and she's my friend. Yeah, and then she participated in a study. It's an online testing study. Then she said, well, I had trouble, because I still like scratch papers. I like to make computations or make some marks, on the paper. So it's an easier and comfortable way for me to learn and to get tested. So indeed, paper testing is still needed, but the population might get smaller and smaller. So the other thing that I often can hear from the market is, well, paper testing might be an accommodation form someday in the future. So the thing will be, well, you don't get a chance to collect a good data for you to do paper equating, but still there might be mode effects as we are aware of. So do you really can use the pre-test items that you get from one testing mode to another testing mode? So this is the study that we try to investigate. The question we try to address in this study for. The purpose of this paper was to evaluate the appropriateness to conduct IRT pre-equating using pre-test item statistics from online testing to create paper conversions. Okay, so I think you see this nice graphs, many times. So this is the materials that we have. So when Wei and I started to think about those questions, and then I asked Wei, so what do we have? Well, I have to say, the excitement as being a psychometrician, this is part of it, like restrictions. You have so many restrictions and limitations in reality, in operational world. It's not a beautiful simulation study. So based on what you have, what can you do? And whenever I thought about this situation, I thought of my mom. My mom was a nurse in Taiwan for 40 plus years, and she worked full time, and she volunteered in hospitals in the nighttime as well. And she had to take care of a husband and the 3 kids. And we are big eaters, as I can see. I ate a lot. My siblings, we all ate a lot. So my mom had to make a lot of food, before she went to work. So oftentimes she had to open her fridge and see, okay, what can we have? What can we make today? What can I make today? What do I have right now? But she will make reasonable food, healthy, reasonable food. It's not a great cuisines from the super fancy restaurant, no, but still it's healthy and it's eatable and it's make us, good person, I think, yeah. So what we have right now at hand is what I'm going to describe to you. And with some limitations, limitations that we acknowledge, we create this study, try to tackle the research question that I addressed.
can we use IRT pre-equating stats from online, use them, to the paper form equating? So as you can see, right, these are all online forms as we described in the very beginning. We have a paper form X. We have a new form Y. And this new form Y actually was split into 4 different field test sections to create the starting forms X1 to X4 that Young referred to, very often in his presentation. Actually, for this base form X and for this new form Y, they are online. They are online versions, but they have their own paper versions. So that would be the treasure that we can, use and borrow to conduct this study. The goal is to do this. We find a paper-based form because it's paper, right? This equating aims to create a paper conversion. And then we want to know if the online stats is applicable, to create a conversion, to equate back to this paper-based form. You can do this through IRT pre-equating as long as you have a stats, right? A good stats for this form and a good stats for this paper form. You can do the IRT pre-equating. But how good it is? You probably want to compare this against a base form that is from the paper testing. So to do this, you'll have to create a new paper form and do an equal percentile post-equating. The reason why we choose equal percentile post-equating is because it's the current practice, for the testing program. So we want to keep, as much as possible, the similarity as much as possible as what we do right now, hoping for that, when you make a big shift from methodologies and test, equate, and testing mode, you can keep other things as simple, as similar as possible. So the graph at the bottom is the goal that we want to do through what we see from the top. And the 2 secret, paper forms, they are parallel to base form X and the new form Y. But the difference will be, like Wei said, there are technology enhanced items in this new form and in these online forms. So what we did is, first of all, we'll have to create the blue thing over there, the paper, shorter paper-based form. Like I said, there is a paper version of this online form. The difference is TE items. And to make them parallel in terms of test lengths, when TD created TE items for the online forms, they created MC or CR items that are content equivalent to the paper forms. But we also know that TE items, they behave differently from these MCCR items because they are content equivalent, but still they are 2 different items. So in order to create this paper-based form, we remove TE items from the online-based form, and we remove the corresponding NCCR items from the paper-based form. So this will give you the shorter paper-based form. And through operational administration, this form is administered. So there's real data. You can actually get the frequency distribution, right, student performance for this base form. And without some items, there can give you another score distribution for this paper-based form because they are single group design. It's basically a single group design. This frequency distribution was just counted for less items than the original one. So we did a concordance analysis. It's like a concord your scores from a shorter form back to a longer test. And then this longer test gives us the base form, the original base form conversion. So through this single group design and then using the equal percentile equating that we feel it's the safest and the most similar to our operational practice, we created the base form for this shorter paper form through concordance. That's the baseline, for us to equate the two, to do the two equatings. So let's go back to this graph again. Now you have this blue little guy in the middle. Now let's take it down with this right part. So the step 2 is for you to create the shorter paper new form. We call it Q, and we need a score conversions too. So again, right, there's a base form online. There's a new form. It's also online. But this new form also has a paper version of it. So when you move TE from the online base, you also can move TE from the online new. And then TD does a wonderful job, to maintain the test spec. So the number of TE items are the same. They are parallel forms. They have the same number of TE items. So when we move the TE items from the online base form, we will be able to move the same number of TE items from the online new form. And this removal of the TE items from the online form, we move the corresponding NC/CR items from its paper version. We work on the paper version, right? Because we need to create the paper form. That paper form equating result will tell us to compare with the IRT pre-equating result, would tell us, how similar that will be, to the equating from this new paper form. And this equating, basically, it's random group design, because this online new form and this online new form, when they are administered, it's a random group design. And then their paper counterpart, it's random group design. So now I'm just cutting it down, to remove some items. So still, overall, it's a random group design. And as I said, to maintain the consistency with the practice, we perform equal percentile equating to yield, this score conversion. And we'll have to admit, this is synthetic, right? Because there's an intact form, and we remove some items from the intact form, and we get the responses from there to do our analysis. So it's not a real intact form, it's synthetic. And the third part is to create. Okay, so this is what we had after step 2. And then remember, right here, that will be the pre-equating IRT stats part. So step 3 is the part that the step we have to get this done. So again, this nice graph, from Wei's presentation, we create this 4 study forms. The OP items are the same to the online form. But in the middle, these are pre-stats. These are pre-item statistics. They are from this new form administered. We split them into this 4 slots. And then originally in Wei's plots, you can see it's A, B, C, D. And here we use A prime, B prime, C prime, D prime just to acknowledge the difference, because we remove TE items from the original A, B, C, and D. And pull this 4 section together, we can have the online item stats and then form it as a form. And this form and the paper form, if you do a IRT pre-equating, then you will get the conversions, right, for this form. And again, these paper forms, as I said, it's a shorter version of the original one. And then this original one also had its item stats, its IRT stats. So to collect, the data to perform this IRT pre-equating, it's through what we propose, the embedded field testing model. We collect the item stats from A prime, B prime, C prime, D prime. And then to perform the equating, we use the IRT true score equating. And in order to perform the IRT true score equating, we need item stats from operational, this OP form, paper form, and this online form. Scales scale bothers us because when you do IRT equating, your item stats, they need to be on the same theta scale. So in this study, the good thing is we try to maintain a pool, an item pool that has everyone aligned to this theta scale of this vertical item pool. And through there, each time we monitor the scaling constants to make sure, we properly put the item stats onto that vertical scale. So we did some rounds of scale transformation to make sure item stats from these pre-tested slots, they are properly transformed onto the theta scale of this operational form. So we have the confidence to do the IRT true score equating. So as far, I'm hoping we are calm and confident and creative, supplementation as everybody, in this session. That's all what we're doing, right? Here comes the result. Okay, so first of all, I'm presenting you the result of equal percentile equating. This table merely shows you, the number of people, the number of students involved in the English 4 and the number of students involved in the English 9. We quit, presenting science grade 3 and science grade 7, well, because after we removing the TE items and after acknowledging that, this new form, when we split the items into 4 different sections, okay, for science, I guarantee you, science had TD specialists. They try their best to help us to put the items into the slots. But the thing is, test length is a restriction. So we couldn't administer as many as items as we wanted here to the pre-test slots. So we lost items. Eventually, for Science 7, for Science 3, the number of items were imbalanced, like 1/3 less for one form from the other. And we didn't feel comfortable. Although it's synthetic, but still it's not realistic. So we decided not to go with the result with Science 3 or Science 7. But for English 4 and 9, the number of items are the same across 2 forms, across IRT online forms and the paper forms. So we go on with English 4 and English 9. And for the equal percentile equating, we look through the smoothing result and pick the numbers that we think that is best, to present the equal percentile equating result. So smoothing value was 0.01 was chosen for this study. And then to do IRT equating, we sort of, go through the test characteristics, curves, TCCs, and the TIFs. And as you can see here, it's interesting. For English 4, the red curve is for your our paper-based form. So red is for paper-based. Blue is for online. Same thing here. They just show different patterns, as you can see. So for example, for English 4, with the fixed theta estimates, let's say theta 1, you actually, have a more capable group, for paper-based form, because you can get a higher number correct score over there. But it's a reverse, situation for English. For fixed theta, actually, it's the online new form stats will give you a better TCC. When I say better, I mean a more capable, group. So we did IRT equating using online pre-test stats, and we do the post-equating using the synthetic, paper forms. This is a result for equated raw scores. So for the blue curve here, that's the difference between the equated raw scores through online against the paper base. And the red curves here is the equated raw scores for the paper new against the paper base. So simply put, we have equated raw scores. So we compare them with the base raw score, take the difference. And the difference between the two subjects, well, as expected, they differ. People would be more interested in to see equated raw scale scores, like the reported scale scores, eventually. So this is the raw score to scale score conversions. Again, blue denotes the result for the online form, and the red is for the paper form. So here, actually, you can see the relationship very clear, right? So if I'm a student, my raw score is 16. And then to give me a score, if you go through the post-equating using the paper form data, I will get this score. It's roughly 418. But if you score my performance using a pre-tested item stats that you collected from online, well, I'll get a higher score. That would make me happy. But, well, vice versa, right? If I take it online and, well, actually it's a paper test, I'm not supposed to get that, score. It's just invalid in some way because of this mode effect, embedded in the item stats that you collected. And that is the E4 result. For E9, you also can see discrepancies along the raw score scale. So we just simply, plot the result in a different way. So this set of plots, they are telling the same information, the same message as you saw from the previous one. It's just now we take the difference. So again, for a student who got a raw score of 16, I actually would get a higher score if you use the paper form conversion to score me. Because online minus paper, it's minus. And this is the result for E4. There's score difference around 1 or 2 across the raw score scale. And then for E9, there's 1 point, roughly 1 point scores, across 2/3 of the raw score scale. Then will this difference, make you feel comfortable to move on? It's kind of, subjective, right? So here is our concluding remarks. So pre-equating results, result in differences from post-equating. And this difference is expected. And we are nervous because the difference at the student level, it can aggregate at a group level. And that degrees of the scores will be hard to explain, to the students or teachers, at least, that's our experience thus far, and that's our concern in the future. Most effects are still a concern. And the other thing would be more technical, like, to conduct this study, there's actually linking errors, as I said. We put estimates on the proper data scale, so there are multiple linkings in this. And also this base form that we use, it's created a few years ago. So we always trouble ourselves to see if at the right time, at a better time, we can have a new base form to retire the old one. And the final word is, well, new form contains pretest items only. In our case, it's an extreme case because in reality, there's operational forms administered with the pretest items. So this extreme case, tell you this difference, but in reality, maybe there will be another situation because you'll have some amount of operational forms, your pre-testing model. Yeah. So I think I'm about running out of time, and I promise you that, you'll see Deb Harris, by the end of today. So before I pass it to Deb, we want to thank Gina to help us, to coordinate this NCME session. And I'm going to stop right now. So the floor is yours, Deb.
Good morning. Can you hear and see? Okay, perfect. These 4 papers have dealt with a complex issue. Changing to pre-equating isn't necessarily that complex, but when you're doing it with multiple assessments, multiple subjects, multiple grades, vertical scale within subjects across grades that you want to maintain, mixed format item types, and a dual delivery mode, it gets quite complex. And I do want to applaud the authors for investigating the issue prior to implementing it. Wei mentioned at the beginning that I consulted on this. I have no recollection of that. So I don't know if that's actually true or she just put that in there so if I said anything bad, I'd feel responsible for it. I'm not actually sure. Context effects seem to me that they're often ignored, and I think it was important that they were investigated here. The authors looked at multiple grades and subjects, which I thought was good. It's not really practical to look at every grade, every subject, every item. Would have liked to seen a little more of the TE items and CR items in the pretest sets. And I would have liked to know if the items that were serving as pretest items in this study were similar to real pretest items, or if they were really more like operational items. Because when you have a program that currently post-equates, there are often tweaks or changes between what's pretested and what actually goes on a form, because you're allowed to do that because you're post-equating. So if these items are really operational items and not raw pretest items, the results may look a little better than you might expect in practice. I do really like the fact that they looked at the effect on the operational items for the different pretest forms. I think too often when we are looking at embedded field testing, we're looking at what's the effect on the field test parameters? How do we get the best field test parameters? But we don't spend enough time thinking, is that affecting the score of the students who are actually taking those pretest items? Are they spending time on them and therefore not having that time to spend on the operational items subsequently? So I think it was really good that that was investigated here. They showed us a lot of data. An additional thing I would have liked to see is the amount of time spent on the pretest units by form. I think it was a nice design. Well, obviously, if I actually helped design it, which I have no recollection of, but there's a base form, there's 4 different pretest item forms, and a new form assembled from those. I would have liked to see an analysis on how the pretest items in the base form X and the new form Y compared. I know that's not the focus of the study, but I'd like some idea of how stable pretest items are when they're embedded in different operational forms. I would have also liked to know a little bit more about how the 4 sets were assembled, but I think I got that information from some of the later charts that they were basically taken as sections. A items were in sequence, B items were in sequence, C items were in sequence, and D items were in sequence. I think the fixed parameter calibration for the pretest items makes sense. I would have also liked to see calibrations on the operational items for the X1 to X4. The reason why is those are the same identical items. So to the extent those calibrations would differ, would give you some idea of what the random error is. Because throughout the study, we're not comparing, or we shouldn't be comparing, pretest. It's not like a simulation where you're comparing, the pre-equating to truth or the pretest calibrations to truth. What we're comparing to also has error in it. So I think there are a couple of cases here where some additional analysis would give you some idea of what that baseline really is, because it's not 0. So for example, if the parameter estimates across these forms differed by, I don't know, on average, 0.1, then differences that you're seeing with the pretest calibration and those items operational, any difference around 0.1 is just what you'd expect by random error anyway. So I think it may give you a little better comparison. And I'm big for having any sort of benchmark data to help me interpret results. So I think there's a couple of places where this would just help see how much of this is random error that I'm not going to account for, even if I did the exact same thing over again. I thought the Lincoln design was great. There were some issues. Not all the items had pretest stats. The random groups design is an incredibly robust data collection design, especially for linking, equating. If that's what you're going to have in the future going forward, then excellent. But if in the future you may be pulling some pretest items from last year's administration and some from next year's or this year's administration to put together a form for next year, all those equivalencies you get by having random equivalent groups won't necessarily hold. So I don't know if it's possible with the sample sizes you have, if you could, go a little smaller on those sample sizes, delete some people, so you have somewhat less equivalent subsamples to estimate the pretest stats are and to subsequently conduct the equating. I think the fact that you used random groups was great, but I think if you're not going to be able to maintain that going forward, that there may be some additional variability that's not showing up here. And again, I think if you could equate form Y to one of the X forms or all of the X forms, you might get, again, some idea of the random variability you'd get that may help serve as a baseline for when you're interpreting the equating you're most interested in. So again, I don't think any differences are necessarily attributable to the change in methodology. I think there's some part of those differences may be just random. And depending on where things round, you may or may not see differences. So I might try doing kind of replicating what you did with Y by equating not just to X, but maybe X2 or X3 or any one of the X's also, just to see how different those results would be. And again, just to kind of get an idea of the random error. I think the set of analyses conducted were quite extensive. And I really liked the fact that you applied the conversions to a set of operational data, that you didn't just look at, this is the difference in the conversions, that you actually applied it to a set of data and looked at, so what would actually be, classification differences, and differences in the tails where you have nobody scoring versus differences at a cut point. I thought it was really good to look beyond just the conversions. There were some context effects that were found at the item level, and I think what you've shown is what we used to see happening also in scrambled test forms, that sometimes those differences held up across forms, and sometimes they were compensated and basically canceled out at the form level. So if you're pre-testing everything in the middle, and some of those items move earlier and get easier, and some of those items move later and get harder, it's possible that those will cancel out, and at the form level, it really won't matter. So I think that's a good thing to keep monitoring over time, and hopefully that will continue to happen. Now, it won't happen. So I'd also look at bullet number 3, if there are ways to adjust the stats. So over time, you're going to build up a lot of data of this is the pretest stat version, and then a subsequent operation version. So look to see if there's a regression or some other analysis that can help predict what the operational will be in a more refined way. And that may be something to use in the future. For example, if you decide at some point to use this pool for CAT, you would want to be able to look at, not just the pretest stats, but also different position stuff. I think the comparison across modes was a nice add-on to the studies, and I appreciate the difficulties. And you explain this a little better than in the paper I wrote, or I missed it. Pretest items will still be in paper. So it seems to me there are still some comparisons you can do by using the actual paper pretested versus the online pretested to see how different those are. The differences you found, I'm not really sure, are they due to the mode effect? Are they due to leaving out the TE and the TE equivalent items? Are they due to having different non-equivalent samples maybe? And I'm not really sure, and this isn't a criticism, I'm just trying to think in my head, what is the real comparison to make? Is it the paper equal percentile to the paper pre-equating? Is it the paper pre-equating to the online pre-equating, or is it the paper pre-equating to the online equal percentile? Depending on how the scale was set originally, I'm assuming at some point there was a mode study that looked at the differences between paper and online. So there must be some data that helped convert online or paper to online or online to paper. And I don't know if maybe there's an adjustment that could be made to these pretest stats that would help make it look a little tighter, because you've got the two things going on. You've got the pretest to operational, but then you've also got the mode difference. So there may be some sort of, I'm just calling it adjustment because I'm not sure what it would be, that would help make it a little closer. And you've got some history data where you have online forms and paper forms that are similar. So you might be able to just look at those item stats at an item level and see items like this tend to get 0.1 easier. Items like this tend to get point whatever more discriminate. There may be things you can look at using the operational data that you have, because those items, for a lot of cases, are identical across mode, and look at what's the difference mode-wise. I know there's a sample difference too, but see if maybe there's some adjustments or tweaks or something that you could make that might help that. So in summary, do I think that these authors demonstrated that there will be no impact? No, I don't. Do I think there's any set of analysis that would indicate, that would show, that make you think there's never going to be a problem? No, of course not. So do I think that the changes can proceed? I would say a qualified yes. I think there's still some issues that need to be addressed, especially kind of with the paper. But there are different ways to do that. You might actually pre-equate in a different way for the paper. Maybe the paper form doesn't match the online form in a year, it lags, and then you're actually trying to pre-equate from an intact online form to the paper form. So you can use some of the data you have in the past. So maybe there are things around the most dramatic differences you saw, but I think that the authors did an incredibly well-designed, well-executed study, and they seem very aware of the differences they found. They're not trying to say, oh, these don't matter, and it's just 2 points, who cares? I think they're very aware that, there can be consequences to changes like this, but I think they're aware of what they are, and they seem willing to monitor them. What I'd like to see monitored is basically everything. What's the effect on the vertical scale? They didn't look at adjacent grades in this, so that would be one thing to look at. Are you still maintaining the grade-to-grade differences with this new methodology, and both across paper and across online? Like to see the ongoing plan for monitoring the pretest positions, the latency, the operational, the scoring of the constructed response items using pre-test item responses, not post-test item responses or operational item responses. I don't know how different that would be in practice. Typically, you get better, training sets from a larger group. The sample sizes here were pretty good if those are going to be maintained, but if you have 10,000 operational essay question results you can pull from, that's a little different than 600 or whatever. So I'd like to see how that would hold up over practice. I think the authors provided a well-developed example of how complex issues can be informed by well-designed studies and very creative solutions to places where what you would ideally like to do, you can't do because you're in an operational setting. The fact that they were able to get operational data on these, I think, made the study much more useful, because motivation of a special study wasn't a strong part of this. It was basically in an operational setting. And I certainly think you deserve a lot of credit for doing this study. I know it would be research intensive to carry it off, but even if the changes are going to be inevitable, they're going to be made regardless. Having this type of study and this type of data is very helpful in forming decisions along the way. There are hundreds of decisions you'll make on how to implement this in an operational setting, and having this data to rely on and to help inform those decisions, I think will invariably lead to a better outcome than otherwise. So I think the work that was spent on this and the resources it involved was very well spent. I think the program will be better for what you've learned in this going forward. And finally, personally, I really want to thank Gina. It took 12 emails for me to be able to get this Zoom link, and I'm very appreciative she stuck with me. She's a rock star. Thank you very much.
Okay, so thank you very much. Thank you, Deb, for your nice comments. Well, a lot of words of, encouragement to us, and a lot of words, for us to do a better job in the future. Sorry, I'm becoming, emotional, because everything Deb said is true. Yeah, people come and go. So we now have limited resources, and we have nice people who we're able to be working with, and we appreciate that. And we also grateful, for the limited resources, because they make us become more creative. And the other thing is, I really want to thank Yong and Wei. The three of us right now stick together and try to survive. And when I say survive, it's actually in a positive tone, because we see challenges, still every day. And there's a lot of issues, as you see in Deb's comments. Yeah, well, a lot of consideration we'll have to take into account to make pre-equating model work eventually, and create fair scores, for students taking tests across different modes. So all the great comments, from Deb is like a good lesson for us to rethink what we did, and the things that we didn't do, and the things we can still, work on in the future. So I really appreciate, Deb, your time reading our papers, and I appreciate, all the people who help us to make this session, to this point as far. And also I want to thank all the audience, participating in this session, with us, yeah, for the past, okay, I passed time, 2 minutes over. So past, 92 minutes. And this is a special year, and today is a memorial day, not a observe the Memorial Day, but it's a special day today. So I hope everyone, can stay positive, as Steve Sarathi told us yesterday in his positive psychology, part. Yeah, let's stay positive. And we are psychometricians, who see challenges every day, but we try to keep ourselves calm and creative and confident by doing well-designed study as Deb approved. So thank you, everyone. Thank you. Stay well.